Greetings of the day to everyone. Today I'm going to cover the topics structure of water, structure of ice, and chemical properties of water. After sp3 hybridization, water molecule is formed with covalent bonding, but due to high electronegativity difference between hydrogen and oxygen, hydrogen gets a partial positive charge and oxygen gets a partial negative charge, making H2O a very highly polar molecule. We already know that water molecule has a distorted tetrahedral shape with bond angle 104.5 degree and OH bond length 95.7 picometer. Now, in liquid phase, when several water molecules come together, they are held by hydrogen bonding. Hydrogen bonding is the force of attraction between the hydrogen of one water molecule and the oxygen of other water molecule, as the hydrogen has a positive charge and oxygen has a negative charge. Remember that hydrogen bonds are not chemical bonds. They are just intermolecular forces. The crystalline form of water is ice. At atmospheric pressure, ice crystallizes in hexagonal form. Ice is a three-dimensional hydrogen-bonded structure where oxygen is tetrahedrally surrounded by four other oxygen atoms, such that OH bond length is 276 picometer and density is lower than liquid water. Now let's discuss some chemical properties of water. Water is amphoteric in nature, that is, it can act as an acid as well as a base. But to understand it, you need to know bronsted-lowry theory. According to it, when two compounds chemically react in such a way that one loses a positive ion or proton and the other gains it, then the one which loses is a bronsted acid and the one which gains it is a bronsted base. I repeat, the one which loses positive ion is acidic and the one which gains is basic. In the first reaction, you can see water tends to have an acidic nature as H2O loses an H plus ion and becomes negatively charged hydroxide ion, whereas ammonia gains that H plus ion and becomes positively charged ammonium ion. While in the second reaction, H2O is gaining the H plus ion released by the hydrogen sulfide and is forming hydronium ion with a positive charge. As it is gaining the H plus ion, it is a bronsted base, while the hydrogen sulfide has lost the H plus ion and has become bisulfide, hence it is bronsted acid here. Autoproteolysis is also caused due to amphoteric nature of water. In this process, two water molecules undergo a chemical reaction. Here, the first one gains the H plus ion and becomes H3O positive or the hydronium ion. Hence it is bronsted base, while the second one, it has lost that H plus ion and has become negative hydroxide ion, hence it is bronsted acid. Now, for this H2O, this is its conjugate acid, and for this H2O, this is its conjugate base, and these both are conjugate pairs. Calling it again, bronsted acid loses the H plus ion to form conjugate base and the bronsted base gains that H plus ion to form conjugate acid, and these both are conjugate pairs. Water can be both reduced and oxidized. Water, when reacts with the highly electropositive metals, as in the first reaction with sodium, it is reduced to dihydrogen. But at the same time, it can get oxidized while reacting with electronegatives like fluorine as shown in the second reaction. Hydrolysis reactions are those when compounds react with water and their bond gets breakdown as they combine with hydrogen or oxygen, and sometimes both, generally forming acids or bases. Here, in this complex reaction, phosphorus pentoxide becomes phosphoric acid. Hydrates are another subject formed due to hydrogen bonding, which crystallizes the salt, that is, water molecules get attached to them. Let's take an example of chlorium chloride as shown in the reaction written below, which reacts with water to form a positive chromium ion and three negative chlorine ions. The positively charged chromium ion so formed attracts the negative pole of water molecules, that is oxygen, as shown in the figure. This is called a hydrate. Here its name is hexaquachromium chloride and is written as shown below the figure. Thank you, and that's all.